All right, so this is the Unit 3 Lesson 2 homework, and I am just going to kind of go through my answers. So summarize Newton's second law in your own words. Obviously, you can have this written however your heart desires. But basically what Newton's second law says is that acceleration is equal to force divided by mass. The other way we see it is F equals ma. But this first one is actually what Newton said originally. He said acceleration is directly proportional to force. And inversely proportional to mass. Or another way of saying is that if you apply force to a mass, it produces an acceleration. All right, question 2. What is a Newton? What does it measure? Well, a Newton is a unit of force. And if we use F equals ma to derive our unit, well, we know that mass is in kilograms and acceleration is in meters per second squared. So if we take kilogram times meters per second squared, that is defined as being a Newton. A trio of students, question 3, push a 65 kilogram crate. The first student pushes with 31 newtons east. The second student pushes 28 newtons south. The third student pushes 39 newtons west. Draw a free body diagram for the crate. So we have our box. It's 65 kilograms. Looks like we've got 31 newtons. That way we've got 28 newtons south, and we've got 39 newtons west. That would be my free body diagram. Let's see. Question 4. For each free body diagram, find the net force and the acceleration. So we've got our net force. Okay. Looks like that we're noting positive is up and right. So our net force is equal to 361 minus 441 minus 112. So that gives me negative 192 newtons, or 192 newtons down. And then I'm looking for an acceleration, so F equals ma. I've got 192 equals 45 times a. So I get a, if I leave that negative sign there, a would either be negative 4.27 meters per second squared, or you could say 4.27 meters per second squared down. Either one would work. Let's see. B, F net, well, in the y direction, 441 minus 441 equals 0. In the x direction, we have 245 minus 135 equals 110 newtons. F equals ma, so 110 equals 45 times a. So a is 2.44 meters per second squared. And it's up. And I should say that here as well. Oh, no, it's not up. My bad. It is right. Letter C. Here, let's see. We've got F net Y 131 minus 441 equals negative 310 newtons, or 310 newtons down. F net X equals 183 minus 213 minus 98 equals negative 128 newtons, or 128 newtons down left. Okay, so Fy equals ma. So we can do, let's see, we've got 310. Negative 310 equals 45 times a. So a is equal to negative 6.89 meters per second squared, or 6.89 meters per second squared down. And Fx equals ma. So I've got negative 128 equals 45a. So a is equal to negative 2.84 meters per second squared, or 2.84 meters per second squared left. All right, question 5. 2 people push a 2,250 kilogram car, each with a force of 275 newtons forward. There's a frictional force of 310 newtons backwards. A, draw the free body diagram. 2,250 kilogram car. We've got 2 people, not 2.75, 275. And they're both doing that much. And friction is backwards. That's 310 newtons. That's letter A. Letter B, find the net force. F net equals, the force is moving to the right, 275 plus 275 minus 310. So this is equal to 240 newtons to the right. Letter C, find the acceleration of the car. Well, F equals ma. So I've got 240 newtons equals 2,250 kilograms times A. So A is equal to 0.107 meters per second squared to the right. If you rounded to 2 decimals, that's fine. 0.11 would be totally fine. And then D is asking for how far the car has traveled after 10 seconds of pushing if the car starts from rest. This is just a Big 5 question review from last semester, so I'm going to make my list just like I did last semester. V1y, it says it starts from rest. We found the acceleration to be 0.107. And the time is 10 seconds. I want to know D. So I'm going to use D equals V1yt plus 1/2 at squared. v1y is 0, so that crosses off. And so we get d, why am I saying y? Great question. That's not y, that's x, but v2d. This is all in the x direction. Screwed up there. So d equals 1/2 times 0.107 times 10 squared. D is equal to 5.35 meters. And forward is the technical direction of that. Finally, last but not least, we have question 6. Two mechanics use pulleys to lift a 105 kilogram engine out of a car. The first mechanic pulls with a force of 675 newtons up and to the right, and at a 21 degree angle, right of up is how you should read that. And the second mechanic pulls with a force of 712 newtons, 33 degrees left of up. The force of gravity acting on the engine is 1,029 newtons down. So draw the free body diagram. A, we've got our car. We know that this is 1,029 newtons down. And we've got one going that way and one going that way. The angle here is 21 degrees. Right from up. And this one is 33 degrees. This is 675 newtons. And this is 712 newtons. And I drew those angles wrong. I drew them backwards. So this is 21 degrees, and this is 33 degrees. Because it's 21 degrees right from up, and 33 degrees left from up. So this is 675. And this is 712. So that's letter A. So then letter B wants us to determine the net force acting on the engine. Okay, so we know that F net in the x direction is going to be equal to, we'll call this one 1 and this one 2, just because I've decided that to be the case. We'll say fx1 plus fx2. So to find the force in the x direction, we're going to need to use components. So we're going to have to break this triangle into, I'm going to use a different color so you can see that, into, that's not the right color. There, let's use blue. X. Okay, so we'll say that's f1x and this is f1y, and this is f2x and this is f2y. So to find that, it's going to be the same up here. Okay. This is f1x, f2x. Okay. So to find F1x would be F1 sine 21. So Fx1 would be equal to, what, 675 sine of 21. Which is 241.9 newtons. Fx2 is going to be equal to F2 sine of 33. So that's 712 sine 33. And that's equal to 387.8 newtons. This one would be to the right, and this one would be to the left. So F at x, the one to the right is 241.9, and the one to the left gets a negative sign because that's left is negative, minus 387.8. So in the x direction, we get negative 145.9 newtons, or 145.9 newtons left. We also need to look at y. F net y equals Fy1 plus Fy2 minus 1029, because that's going down. And so we use sine to find x, so we're going to use cosine to find y. And that's also because this is y right here, and it's adjacent. So we've got, let's see. So Fy1 equals F1 cosine 21, and Fy2 equals F2 cosine 21. 33. So this is 675 cosine 21. Equals 630.17 newtons. And this one is 712 cosine 33. Equals 597.13 newtons. So we have our F net y equals 630.17 plus 597.13 minus 1029. Equals 198.3 newtons, and we are up. So just so we see here, that one and that one are our net forces. If we wanted to know what our net force was overall, this is a y direction, we'd just put it on a triangle. So we've got up is 198.3 newtons, and then we have left is 145.9 newtons. So this is our overall. How are we going to find that? Well, we're going to do a squared plus b squared equals c squared. So we get C to be equal to 246.19 newtons. And then if we wanted to find the angle here, we would take inverse tangent of 145.9 divided by 198.3. And we get 36.34 degrees. So that is our net force and our angle. Then letter C has us finding the acceleration, well, F net equals ma. So our F net was 246.19 newtons, and our mass was 105. So our A is equal to 2.34 meters per second squared. And then letter D says determine how long it will take to lift the engine 1.25 meters from rest. This is another big five. V1, V2, A, T, and D. And we're looking for 1.25 meters off the ground. We got our A to be equal to 2.34 meters per second squared. And we know that our initial velocity is 0. We are looking for time. So we've got D equals V1t plus 1/2 AT squared. Cancels out. 1.25 equals 1/2 times 2.34 T squared. So multiplied by 2. So I get 2.5 equals 2.34 T squared. And so we get T to be equal to 1.03 seconds. And there we have it. That is how you do number 6. Now, technically, based on the way we did number 6, you could go back to number 4 and set that up on a triangle as well. So looking at the overall, we got 128 newtons left, and then we had 310 newtons down. And so then if we found that one overall, we do 128 squared plus 310 squared equals C squared. So our C would be equal to 335.4 newtons. And then that would, so that's our F net. And so F net equals MA. So 335.4 equals 45 times A. So we would get A to be 7.45 meters per second squared. And then that angle would be inverse tangent again, so opposite over adjacent. That's 67.56. So if we're looking for an overall one, this is what it would look like for letter C from number 4.